So they gave us the results for the sample, and they want us to test the claim that the percentage of 40-year-old men who smoke is 22%. I think what I'm going to do here, and I don't always do this, but because they aren't telling us any direction, but I'm looking at the sample, and to me, it would make sense to try to show that to disprove the claim that 22% smoke would be to show that more than 22% smoke. Not worry about a two-tailed test. Let's just go with a one-tailed test, and we'll use we'll use for a null hypothesis. We'll say, yeah, 22% of the people smoke or men smoke, and our alternative will be a one-tailed greater than 0.22. I think this will work. Then we need, let's see, we know p hat. Our p hat's 26% or 0.26. So we need a standard deviation. So we'll assume the 22% figure is true, and 1 minus 22% is, let's see, what is that? 0.78, if I'm doing the arithmetic right. And we had a sample of 140. Notice we didn't even use the 40-year-old men. That's just a categorical situation. So let's calculate this standard deviation. And if I round, I'm getting about 0.04. So now we need a z-score. So the sample result was 0.26. The old center was 0.22. Standard deviation of 0.04. So the z-score is going to be positive 1. Now, I guess we need to, well, we could use the 68, 95, 99.7 rule to come up with a guess. So 68% of the distribution falls within one standard deviation of the mean. That means 32% fall outside, and half of that is 16. So to write this as a decimal, we'll know there's 6.16 is going to be about the p-value, but we want to look at table B to get a little bit better value. So looking at this table B, we want to find a z-score positive 1, which is right there, 0.8413. So since we want to go to the right of that, because this, remember, table B tells us this area here, and we want this upper area because HA is a greater than. Okay, so 1 minus 0.8413 works out to be 0.1587. And that's the p-value.